versus objects in Python. So if you want to learn everything about closure and want to understand how it is related or different from objects, then please watch this video till the end. I'm going to tell you with the code, hands-on coding and a demo and definition, everything. If you have not subscribed the channel, please subscribe, leave your honest feedback as comment. Thank you. So let's get started. What is closure? A closure is a function object that remembers values in enclosing scopes even if they are not present in memory. What does that mean? So once you see live demo, you will understand more. But here, let me help you understand. Python supports functional programming, which means a function can return another function, right? And then a pure function is a function which runs, like when you run it, you execute it and it's done. It doesn't holds the value of the whatever is inside that function in memory, so it gets reset every time when you call. But here, if you see in closure, whatever is the state of the variable that is captured and it remains inside that function, that is how the closure works. So I'll come more detail on this, because here we are trying to show you how decorator and closures are attached. But in general, there is an external function inside which there is a closed function or an enclosed function, which is called as closure in simple terms. Again, I repeat, there is a function and you have another function defined inside a function. So the function which is defined inside a function is called as the closure, and you return that function when you call the outer function. So I think it's too much. Let's try to understand and let's go. So first, this is a pure function. Pure function. Let me help you understand this, right? So what you have is, you have a value, for example, x over here, and then what you will do is you will print value of x, and then whenever you try to execute this, now let's try to run this. Now you're passing the value, for example 12, and then let's run it real quick. You see the value of x, actually this should be x. So whatever number of times you call this, it would always print the same value. Is it clear? Or whatever value you will pass, it will do the same thing. That is what a pure function or a normal function does. But when you try to basically define a nested function inside this, so let's create another function. You call this def multiplier multiplier of. This is an external function, and then you can pass a multiplier, whatever a number, and then what you are going to do is you will define another function with a function multiply multi multiply with, and then you can pass another number, whatever, or here you can pass x for say. And what you are going to do is you will return m multiply with x. So please remember that now you have to return the inner function. Otherwise, how would somebody would call it, right? So you would say multiply with, right? And no braces here. So now let's understand, this is an outer function, like which starts from here, and then you have a nested function or an enclosed function. And now when you call this function, the outer function, it is going to return you the function object of the inner function. Let's do that. So I have a multiplier object or a function object, wherein I would call this, and I would pass the multiple of 2's basically, right? And what you can always do here is you can also print this before returning it. So now print. So what is happening? Let's run this. So this line number 16 calls this function, which will in turn return this function, and this won't be executed. So the closure, whatever the closure, is being returned to this function. If you will just print this guy here, let's see what you're going to get. You will just get the function multiplier and nothing else. So now you have to invoke this, right? So what we are going to do is with this object, if you can pass, I know 2 times 10 is 20. So now you will pass this, and let's see, we got 20, right? Now what will happen is I am using the same object reference, and I am going to pass is 2 times 5, 10. Now, the thing which is interesting over here is, let me remove this print statement, that from we are passing just one value and still we are getting the multiple of 2, the entire table of 2. How is it working? This is working because the value of the variable has been stored in the scope of the function, which is called as enclosure or the closure. Now again understand, the closure is a function object that remembers the value in enclosing scope even if they are not present in memory. So when you define this function, the m got stored. You can always say or define inner scope is equal to m. So this is temporarily defined over here, and now what you can do is you can just define this. So whenever you are calling this function, you're passing one value, and at the multiple runs, this value is being stored in the inner function. Let's try to run this again. So this is how you are able to see all the value, because this inner scope has been saved inside the function. However, in the pure function, whatever value you are trying to pass, it will just go in the parameter as a local function, and once it executes, it's done. Nothing much will happen after that. So there is no variable state which is getting saved inside the function in a pure function, but in the closure it is happening. Now let's understand, there are multiple things which are happening. So first thing is this is enclosure, like this part, right? And then this we can call it as a decorator. And if you pass any function to a decorator, then what it is going to do is it might apply that function. To define decorator, you need closures. This is the key point. And what is a decorator? Which takes a function as the argument, and then it modifies its input or output based on what, like, it intercepts. So what we passed here is a value, right? Instead of value, if you pass a function, and then that function will go through the closure, like whatever is the closure function, then it becomes the decorator. That's the simple concept. Now the last and final concept is how it is related to object, because what we are doing here is saving the state of the object. So same thing can be done pretty easily in Python. And I have a multiplying class, and then what I do is I will create the instructor with the init method. Once I have the method, I can define the multiplier, and I would say like this, right? So I now have a function, basically an object. So this object will always have the value stored inside the object, and then whatever the value I would pass here, I'll just do same thing, nothing different, same thing, and the outcome would be same. So instead of telling the scope of this variable, which was the nested function, What we need to do now is we will use self.m, because now we are dealing the same thing in terms of objects, right? So this is a class, it has an object has a state. Once you instantiate the object, so I would say m is equal to multiplier object, and then I want a multiplication table of 2. So as soon as I will say m dot multiply with, and then I would say 10, it should print 20. Let's see if we face error or 20. So we got 20. If I say, if we multiply this with 100, then it should be 200. See, so we saved the state of the object, like inside the object of a variable. This is pure object orientation. But if you don't want to create a class or the object, and still you want to hold on the state of this, whatever the state of we called as the object, we want to save that variable here. You can do or achieve the same thing inside a function by saving the value inside the inner scope of a function. So whenever the function is getting called, just like pure function, it doesn't like fire and forget, like once you run it and then you're done once function is being executed. No, it will keep on saving the state of the variable inside that function scope, like here. And whenever you're calling that function object, you can pass different parameter, but whatever value you have passed initially, that would remain stored. For example, now I'll do 5, right? So all this value should become the multiples of 5. See here, right? Because we change this value when we instantiate the closure. So now the inner scope has this value 5, and whenever you're calling this function, basically this function is returned here, and then whenever you're calling it, it would use this variable enclosed variable scope, and it would run it. So that was the short summary. I hope you guys like it. To have the quick recap, we learned about pure function, which will just return whatever is being passed, and they will be forgotten. Then we learned about the objects and the class. So the class, when you create the object, you will have a state which can be remembered whenever you call that object, and the method, right? So we did multiplication table with object oriented way. Same thing without using the class, we did nested function. We enclosed enclosure function, and then we were able to save the some variable scope inside it to achieve same result, but using the functional programming type of coding. So thanks for watching. Leave your honest feedback. If you have any questions, just leave on the feedback. If you think it was a good video, hit the like button. Thank you and bye.